Today we're going to talk about the properties of functions. Before we begin, try the warm-up. Find the domain and range of the following functions using your calculator. Pause the video, and once you have done so, hit play. So if I look at the graph of the first problem, 10 minus x squared, I can see that it's a parabola opening down. So the domain has no restrictions. It doesn't follow any of those three restriction rules. That means the domain is all reals. The range, however, our y values, does not include all reals because it stops right here. And if I look at my graph, that point is 0, 10 that it stops at. So the highest y value that I get to is 10. So for that answer, the domain we said is all reals, negative infinity to infinity. The range is from negative infinity up to 10, and it did include 10, so that's your square bracket, your hard bracket. Now for the second one, if I look at the graph of that, it looks like this. The domain is not all reals anymore because it is stopping here. Now we could have done that algebraically by setting 4 minus x greater than or equal to 0 and solving. We get x is less than or equal to 4, or in this case we can just look at the graph because that's what the direction said. So the domain is from negative infinity to 4. Now the range, well, what's that y value? If I'm not sure, I can go to the table and look at that. At 4, that y value is 5. So I go from, again, I start at 5 and it goes up from y. We're looking up and down, so that goes to positive infinity. So domain is from negative infinity to positive 4, and that 4 is included, and the range is from 5 up to infinity. Alright, so that was just a little review. Now we're going to talk about something called continuity. So what I want you to do is pause the video and copy this chart into your notebook. So the class is going to look at the textbook and fill this chart in using the textbook. You can find this in one of two ways. You can go to MathXL and log in and look at Unit 1, Day 4's assignment and get the question help. Go to the textbook pages, there it is. Or you can pause the video here and just look at the textbook here. I'm going to move it down in a little bit, so hit play if you want to keep seeing the next part of the page. And here's the next page, 85. Again, pause if you need to. So now you should have that chart filled in. I just want to go over it. So if we look at the chart, the definition that they gave us is that graphically, a function is continuous. Graphically, a function is continuous at a point if the graph does not come apart at that point. If the graph does not come apart at that point. In other words, under the characteristics, when you draw your graph, you don't pick up your pencil. So when you draw the graph, you don't pick up your pencil. That's a graph that's continuous. When you draw the graph, you don't pick up your pencil. So for example, one example is f of x equals x squared. A parabola is continuous. Another example, here's a picture. If I draw it, I don't pick up my pencil. So something like this, I didn't pick up my pencil to graph it. Other characteristics is that it contains no breaks, gaps, or holes in your graph. So there are no undefined points. So a non-example would be the tan of x, y equals tan of x. because we do have breaks. There are undefined points here, and I can't draw this graph without picking up my pencil. Now we had three different types of discontinuity. We had one called jump discontinuity, where there is a hole and then it jumps and picks up in another spot. That's jump discontinuity. We had something called removable discontinuity, where there is basically just a hole in the graph and then it picks up and keeps going. And then lastly, we have what is called infinite discontinuity, and that looks something like this. So there's your examples for continuity. So now practice a few. Given each of the functions below, determine if it is continuous or not. Once you have finished, press play on the video. The first one is a quadratic parabola, and I can draw that without picking up my pencil, so that one is continuous. The second one is one similar to what we looked at on the warm-up, and it is a square root function. Again, can draw without picking up my pencil, so another one that is continuous, so it would help if I spell it right. And then the last one has two different breaks in the graph, and it looks a little something like this, because we have two spots of the domain that are restricted, which we could find algebraically as of last class, and this one is not continuous because I have to pick up my pencil to draw it. Okay, so there you have continuity. Move on to the next video to review a little more vocab.